Hello, Christian Horn here from the Swedish Rock Art Research Archives. Today we are in Kville in the county of Tanum at a rock art site which is quite well known for a very long boat that is here. It's very long, it goes from all the way over here to all the way here, so it spans the entire panel. What's special with it is that it's very long, over 3 meters, but very, very narrow, not as tall as other boats.
This area of Kville is called Hagarna, and it's very dense with rock art, some of which real masterpieces. One of the most famous is the Ardeloo blowers, which are some 300 meters away from here. Right here we have the 408 and the 409, so 2 different rocks. On the next hill we have 2 rocks. Behind us we have some rock carvings, and also the area itself with the lower parts where either the sea still was in Bronze Age or it was slowly turning into pastoral land. So it's a very beautiful, very interesting area. If you look at the surface from here with midday light, there's nothing to see because the images have the same color as the surface itself, but it's packed with boat figures and human figures, and the only way to find them is to go down on your knees and feel with your fingers, starting the dialogue with the rock. Then you will feel that what is carved is smooth and it's even in depth.
We have been here earlier this year with Mark Peternell from the Geological Department at Gothenburg University and used a device that measures ultrasonic waves going through the rock. The purpose of doing this is that it tells us about the structure of the rock and about microscopically small fractures in the rock. We use this information to inform us both about how people in the past may have made the rock art here, how they were able to break the rock, but also to see what the current state of the rock is for preservative measures in the future.
So from the geological point of view, these rock carvings represent some physical damage to the rock surface, So if we want to understand how the carvers produced these rock arts and what their understanding was about geology and the rock structures, then we have somehow to understand the mechanical properties of these damaged zones. So for this we need to compare these damaged zones somehow to the undamaged original rocks. But of course we must not damage these beautiful images. No. So we have to find some non-destructive techniques to measure or to get information about the structures inside these carved zones and outside. And for this we are trying a new technique here. Well, it's not a new technique, but it's new for this type of research, and that's an ultrasonic device. So what we are doing is actually we will measure how ultrasonic waves are propagating through the carved areas of the rock and the uncarved areas of the rock. And then, based on the pattern, on the signal we get, we try to understand what are the rock structures, what are the typical patterns in the carved areas that are causing different signals to the natural rock patterns outside.
Do you expect a different signal?
Yes, I think I expect a different signal, because when you think of how they put in on these carvings, they must have somehow mechanically treated the rock. So maybe smashing with some tools or so on the rock surface. And any mechanical treatment of the rock will cause something that we call microfractures, so very, very small damages very close to the surface of the rock. And these ultrasonic waves are very sensitive to this type of damages in the rock. So I expect a real difference between the propagation of the waves inside and outside carvings.
So it also makes sense to test different areas where the rock is carved in different depth.
Yes. So different areas, it must be done on a statistical level, so we have to do a lot of measurements. And we can also do some type of area scan, so we can scan whole areas and create some surface, or maybe we call it damage maps or rock damage maps, and see what the pattern looks like. And the idea is, the main goal is not that we identify the carvings, but we try to identify a typical pattern that is caused by a typical carving technique that the people used. So maybe if you use different carving techniques, you may get different patterns, and that is what we are interested in.
So done. Let's try it, right?
Yep. Let's give it a try. So these are the two sensors. And we start the measurement. We see here the signal, and I place
first we go inside a long ship image here.
Yes, so I put the sensors in a defined distance, so this is about 6 centimeters. And then we get our first signal here. Yep, that's fine, okay. And then what else? I will immediately measure somewhere outside, clearly outside the ship, with the same distance, get another signal. And then we will measure some different motifs. So we have here, in this area, we have here some legs of a person. So I have to lift this a little bit. So I go inside the legs and we make another measurement. Okay. Again, I make always control measurements, so I go outside the legs and make another measurement. And a third,
a deeper one, right?
Deeper one was a cup mark.
Okay.
Yes. So we try to measure inside the cup mark, like this one. And again, some controlling measurement outside. Yeah, and now we have this pattern recorded, and then back at the university we will look on the signals and then try to find some typical pattern.
Yeah. Today we're here to use the nice dry and sunny weather conditions to take photographs to create a 3D model using structure from motion. Unfortunately, the wind is blowing relatively strong and the leaves are rustling and moving, the shadows are moving across the surface. So we take a lot of photos and hope that they work in the end.